Welcome to Tammy's Maths or Miscellaneous. How many knots? How many knots? Noughts. How many knots are there at the end of factorial 1000? Knots is 0, isn't it? Knots is 0. How many zeros will be there at the end of factorial 1000? I'll give a very small example. How many knots will be there at the end of factorial 5? Let's take it like that. A small example. So this is 1, 2, 3, 4, 5. Every 5 and 2 will give you a 0. Every 5 and 2 will give you a 0. Every 2 will not give you a 0 because associated with every 2 you should have a 5. Number of 5s will be less and number of 2s will be more. Okay. So how many 5 is there? Only one 5. So there will be only one 0 here. This 5 and with this 2 it will be 0. And you know what is factorial 5, don't you know? So what is it? Only one 0 is there at the end of factorial 5. So it is 120, no? Factorial 5. 120. How many zeros are there? Only one 0 because there is only one 5. Fine. Now, let me come for this. Lovely question. This is a lovely question. How many knots are there at the end of factorial 1000? Factorial 1000. So 1, 2, 3, 4, 5. Then it goes from 10 like that, no? 10, 25 and so on it goes. Fine. Every 5 will give you 1 0 because associated with every 5 definitely you would have a 2. For example, if you take this 5, there's a 2 here, or you can have a 2 even from this 4. But every 2 will not have a 5. So every 5th place will have a 5. See, this is the 5th place. This is the 5th place. This is the 5th place and so on. So every 5th place the greatest integer. The greatest integer. Every 5th place. We are having remainder, we are not bothered. Every 5th place will have a 5. Every 25th place, that is 5 square, is having 5 2 times. But only one 5 is counted here. So one 5 is left out. So every 25th place, there will be again one 5 which is not counted in this. The greatest integer of this. There comes a remainder, we are not bothered. Plus. Every 125th place, there is 5 3 times. There is 5 3 times. But 1 5 is not counted in this or in this. There will be 3 5s. 1 5 will be counted in this, 1 5 will be counted in this, 1 5 won't be counted. So that will be counted in. Next, every 6/25th place, that is 5 to the power of 4, that also will have a 5 which is not counted in this or in this because there will be 4 5s. After that, 625 into 5, that is 5 power 5, 5 square, 5 cube, 5 power 4, 5 power 5 it will become, which will exceed 1000. So we won't have that. Now we will see. What is the greatest integer here? 2, 0, 0. What about this? 4, 0. What about this? What about this? 1, 0, 0 by 125. You can divide like that or you cancel with 5. And again 5 you cancel. So it will go 8 times. Or you can actually divide. I just did this. You can actually divide also. I just did this because I thought it will make it easy. Otherwise you can divide 1000 by 125, which will be 8. And what about this? The greatest integer will be only 1. There will be some remainder. But we are not bothered about the remainder. We are bothered only about the greatest integer. So plus 1. So 200 plus 40. 240 plus 8. 248 plus 1. 249. So when you expand factorial 1000, how many knots will be there? So sweet the languages. It doesn't even say how many zeros are there. How many knots will be there? There will be 249 zeros when you expand. I mean to say when you multiply that. Every 5 will give you a 0. Every 2 will not give you a 0. Because number of 2's will be more and number of 5's will be less. So this is a very interesting question based on permutation combination. So we will see in the next video more questions under miscellaneous. I hope you enjoyed the question.